Dear friends, good afternoon. My name is Vladislav Ivanov. I am a researcher at the Institute of Astronomy of the Russian Academy of Sciences, a senior researcher at the Russian Institute of Scientific and Technical Information, a member of the International Academy of Future Research Center for Future Modeling. Our conversation today will be devoted to industrial revolutions and the prospects of space exploration in the current century. We all live in a fast, dynamically changing world. According to the forecasts of many analysts and forecasters, a very serious systemic transformation awaits us by about the middle of this century. What it will be connected with, how it will look, no one undertakes to speculate. On the one hand, it can be assumed that this will be due to the penetration of artificial intelligence into our lives. On the other hand, this may be due to the exploration of near-Earth space, the Moon and Mars. Accordingly, with the migration of people to these planets. Nevertheless, I would not say exactly and clearly what it will be. What is the reason for this? The fact is that if you put on the time scale, all the significant inventions that somehow contribute to the development of culture, science, technology and technology. Well, for example, like the invention of gunpowder, the discovery of the first printing press, the appearance of an engine, a steam engine and an internal combustion engine. And if you put them on a timeline today, it turns out that the time interval between each of these events is constantly decreasing. By about 2050, a singularity will occur, that is, the time interval between groups and inventions will be zero. And it is your generation that will be the most intelligent and most experienced at this time, having not only professional experience, but also life experience. However, let's move on to our narrative. The first industrial revolution took place in the leading European countries, at the turn of the 18-19 centuries, was due to the transition from manual labor to machine labor. This has led to a fairly rapid growth of production forces. Naturally, the active construction of railways began. And another important factor that is usually not mentioned, which is usually ignored, is the manifestation of gas lighting. It has greatly increased the length of the working day. The work has become round the clock. Accordingly, the capitalists were able to exploit the working class around the clock. What happened next? The influx of workers from the security sector to the industrial sector led to the fact that the concentration of the population was observed near large manufactories. Here on this slide we see a large manufactory, which was located on the banks of the Neva River in St. Petersburg. Then the manufactories began to move to major railway junctions. What is the reason for this? This is due, of course, to the fact that the development of technology, in particular, the advent of the steam engine, led to the development of railways. Accordingly, this infrastructure began to improve and ground logistics began to develop. The second industrial revolution, which ended at the beginning of the last century, electrification and the use of conventional production appeared. The upper slide, picture, shows Vladimir Ilyich Lenin, who was the initiator of the electrification of our country, which allowed us to become a fairly powerful industrial country. Well, on the lower right slide, picture, we all guessed that the conveyor was depicted, which was invented by Henry Ford, thanks to which industrial production began to develop at a rapid pace. As a result, this led to a sharp industrial leap in the general welfare of citizens. It is quite obvious that the well-being of some citizens occurs in all cases at the expense of the impoverishment of others. Nevertheless, the general welfare increased. In countries such as the United States, Japan, and Western European countries, the rapid development of transport has led to the emergence of paved roads. Accordingly, nearby territories near large industrial centers began to be developed. Cars began to appear and separate settlement of territories outside large cities began. Then the third industrial revolution happened, already at the turn of the XX-21 centuries. It was associated with the total use of information and communication technologies, both in production and in other spheres of human life. The results of this revolution have not yet fully spread around the world, but nevertheless, the fourth industrial revolution is already on the way, based on the German concept of Industry 4.0. What it ultimately boils down to, the production capacities of the enterprise must adapt to the new needs of individual consumers and, as a result, This will lead to the release and individualization of products, the complete exclusion of human participation from production. These are the goods in the foreseeable future. In principle, they are not uncommon in some Asian countries now, so individualized products will no longer be something out of the ordinary. As an example, I cited NuScale reactors, which are hundreds of times smaller than classic reactors. This will make it possible to provide electricity to small cities, insofar as hydrocarbons and, accordingly, fuels based on them are eternal, and the alternative to renewable energy sources such as wind turbines is generally not productive. On this slide, I briefly summarized the results. One more time. Industry 1.0 is production based on mechanization and the use of steam and water energy. Industry 2.0, production based on mass production, sequence of conveyors. Industry 3.0 is information technology and automation. And what we have now is Industry 4.0, production based on the use of cybertechnical machine-to-machine interaction schemes. What you need to pay attention to. The fact is that any production cycle always begins with the extraction of raw materials, and ends with the actual consumer products. But the development of automation of all processes in the foreseeable future will lead to the fact that all the most time-consuming operations will no longer need human labor. As a result, people will have a huge amount of free time to engage in creative activities. It's good or bad. Of course, on the one hand, this is wonderful, but on the other hand, the potential side of this process will appear better. There will be no need for certain specialties. I think in 10 to 15 years such professions as a bank operator, a store clerk, a public transport driver will be in the past, and they will be completely replaced by artificial intelligence. The question of employment will immediately arise, because a huge number of people in almost all countries work in these areas, and where these people will go, a very difficult problem will arise. Accordingly, you will have to either retrain or adapt one way or another. As an example, I cited the dismissal of lawyers. More than 450 lawyers at Sberbank, this is the largest bank in the Russian Federation, were fired. Lawyers who prepared lawsuits were fired due to the fact that the neural network prepares such statements much better. And here is a quote from Hermann Greff, chairman of the board of this bank. I will read it out. Banks will probably have no place in the new world and will be completely replaced by artificial intelligence. It's actually not so good when a large number of professionals in their field are released. At the same time, the division of labor that defines the social structure of our society in technologically advanced countries will greatly change the social side of life. Society will no longer need qualified personnel and, in general, very serious changes will begin to occur in society. Therefore, one of the most important resources that will need to be possessed is the ability to retrain. Therefore, even now, at a fairly young age, it seems to me that you will need to be able to retrain, and those people who plan to engage in intellectual mental work throughout their lives will have to study and retrain, unfortunately, throughout their entire lives. Here we come to the fifth industrial revolution, the so-called Industry 5.0. It is expected that it will be the next technological revolution, which will happen much faster and will be on a larger scale. The breakthrough in the field of artificial intelligence, robotics and machine learning, in general, was the reason for this industrial revolution. This revolution will most likely be a transformation system. It will take place in parallel with the fourth industrial revolution. But nevertheless, this is an industrial revolution that will include such things as the Internet of Things, robotics, artificial intelligence, big data. This will happen not only in the industry, but also in the social and economic spheres. This was the next stage after the fourth industrial revolution, in which capitalization concerned production and business. Industry 5.0, it will penetrate so deeply into all spheres of our lives, that it will change the actual social structure of society. The important points that I would like to draw attention to are technological patterns. They differ slightly in their names and in their sequence from the industrial revolutions, nevertheless they are rigidly interconnected. I will read out a clear definition to you now. The technological order is a holistic and sustainable education, within which a closed cycle is carried out, which begins with extraction, obtaining primary resources, and ends with the release of a set of end products, corresponding to the type of public consumption. Technological observations, which are determined by the formation of an individual technological structure, are called a key factor. The complex of basic aggregates of technologically coupled production forms the core of the technological structure. What is the core of the technological order? This is actually the invention that prompted the transition to the next technological order. Here on this slide there is a summary table showing what technological patterns and their sequence are. We are now living in the era of the fifth technological order: robotics, computing, laser and telecommunication technology. And in the foreseeable future, there will be a transition to the sixth technological order. What will be its special feature? This is likely to be the so-called convergence of nano, bio, information and cognitive technologies. That is, all these technologies will be disconnected into one common whole, and in one way or another affect our lives. The numbers of technological structures and industrial revolutions are slightly different from each other, but nevertheless, it is worth understanding that we are now living in the era of the fourth industrial revolution and the fifth technological order. As an example illustrating many of the results of industrial revolutions and technological structures, I have quoted Friedrich Engels. I will read it out: a society that organizes production in a new way on the basis of a free and equal association of manufacturers will send the state machine to where it will then have its real place, in the Museum of Antiquities, next to the spinning wheel and with a bronze axe. And I would like to make another interesting quote. This is a phrase of the President of the Russian Federation Vladimir Putin, which he uttered at a meeting of the Valdai Club in Sochi in 2016. It sounds like this: the future does not call, it scares. Unfortunately, we must admit that the future is quite difficult to write in detail, and what negative moments we will expect in 20, 30, 40 and more than 50 years is quite difficult. We can only assume and rely on some forecasts or scenarios. I have just announced some of them to you. But nevertheless, it is possible to formulate quite clearly what our future will be in the near future with a very big stretch. We have come to the second part of our report. It is dedicated specifically to space expansion. Human space exploration is the most important and inevitable stage in the development of our civilization, which began back in the era of the Second Industrial Revolution. Space exploration will take place one way or another, even though active space exploration has not been taking place over the past 50 years, despite all the forecasts that were made at the beginning of the last century. We have not colonized the Moon, we have not colonized Mars, we have not built any serious large orbital stations in near-Earth orbits. Nevertheless, all the world's space powers are currently trying to voice their plans for the exploration of near-Earth space, and, above all, of course, the Moon. We do not consider Mars in this case, because the exploration of Mars, as Elon Musk so actively argued, in general, this process is very long and very difficult due to the fact that Mars is at a very great distance from us. Therefore, in the next 50 years or so, there will only be active exploration of the Moon and near-Earth space. And, as I said, all the leading space powers have announced their plans to explore the Moon. What is the reason for this? Well, first of all, it is a demonstration of the technological progress of a country. Secondly, the development of cosmonautics in one way or another provokes and spurs the development of high-tech areas. And thirdly, it is the exploration of space resources. In about the next 20 to 30 years, there will be very many minerals left on Earth, in particular, rare family metals that are actively used in the production of hydroelectronics. And humanity will have to explore space one way or another in order to replenish its reserves. Another important reason is that it is caused by man-made, natural and anthropogenic disasters, which will put the problem of human survival in the foreground, and humanity will have to somehow look for a new environment for its habitat. Therefore, in the official documents of the program of space agencies of the world's leading space powers, and even in the United Nations, there is nothing more or less specific about the settlement of mankind beyond the Earth, but quite ambitious plans for the development of space resources, in particular, the Moon, are constantly being voiced. For example, the Artemis program, which was announced in the United States and which attracts other states. Nevertheless, these are quite selfish interests. And other states, which they attract to explore the Moon, are needed directly in order to get technologies for their use. Therefore, as soon as the Americans get to the moon, they will most likely explore it without paying attention to international space law. Well, as an example, I illustrated with a picture like this. It says the following: I think it would be fair to take everything away from you and divide it. This is the position that the United States will most likely adhere to. At the same time, a fairly powerful competitor is entering the world stage in the form of China, which also has claims to the moon. In any case, the exploration of the resources of the moon will be the first steps of mankind in the exploration of the world's, first of all, of course, our solar system. It is quite obvious that any state needs to ensure priority in this regard, and this priority will most likely be due to the creation and construction of permanent lunar stations. It is thanks to lunar settlements and lunar bases that it will be possible to effectively develop the resources not only of the moon itself, but also the resources of the solar system. The delivery of comets and asteroids rich in various minerals and mineral-forming elements is already a matter of the not-so-distant future. There are a huge number of technologies for transporting, processing and similar small space bodies. The plans of many countries for the exploration of the moon provide for the period of the surface of lunar bases, and the construction of these bases will most likely be carried out through 3D printing. Nevertheless, to protect against cosmic reactions, all these lunar bases must be covered with a significant layer of regolith, a substance that is located on the surface of the moon. Of all the major global space powers, the United States now has a fairly clear and distinct position on the moon, and they have already begun to take the first steps towards its exploration. Despite the fact that this slide now shows the project of the European Space Agency together with Foster and partners, this is exactly the same Foster, a famous architect. This is just a tourist base, and it will most likely never be implemented. That is why I would like to emphasize once again that the United States now has a clear and distinct position, and is taking the first steps to explore the moon. Well, here is a lunar base called First Base, which was developed by Bigelow Aerospace, for a crew of 6 astronauts. It consists of 7 modules, including residential units and several docked modules for power storage and an all-terrain vehicle. The European Space Agency also has a well-thought-out program, but it is constantly being adjusted and, in general, the European Space Agency has not yet taken any serious steps to explore the moon. Nevertheless, according to the European Space Agency, in the period from the 20th to the 30s, mapping of the moon's surface and the development of a launch vehicle should take place. But in general, the whole epic should stretch until the 60s of this century, when the first lunar bases with a full cycle of life support systems will be taken on the moon in order to be able to deliver astronauts and conduct certain research directly there and produce industrial processing and processing of minerals. A few words about the Russian lunar program. Unfortunately, it is even more vague than the program of the European Space Agency. Despite the fact that the plans are quite ambitious, clear, approved by Roscosmos, plans are limited only to launching 3 spacecraft to the moon: Luna 25, Luna 26 and Luna 27. Unfortunately, a few months ago, the finally launched Lunar Lethal Station, the automatic interplanetary station Luna 25, was unable to make a soft landing and crashed, so there will be a complete adjustment of all further missions. And this, of course, is very sad, but nevertheless it is a fact, and we need to come to terms with it. This is about how the lunar base appears to different artists. We need to understand that fiction and our realities are completely different things. The fact is that the surface of the moon is a very extreme environment. First of all, there is no atmosphere there. Secondly, there is a very low gravity. And thirdly, there is very high radiation on the moon. Plus, the bombing is incorrect. So all the buildings that will appear on the moon, they will be buried in layers of soil, and it will be quite difficult for architects and designers to disperse there. That's how the first house looked like. This project was developed in Russia. It was the world's first lunar station. It was called Leningrad. But now, after almost half a century, we understand that this project would never have been implemented as a result of its high cost. The fact is that launching a spacecraft into low Earth orbit costs about $50 million, and regardless of which country it happens in Russia, China or the United States, a soft landing on the moon is already an order of magnitude more expensive. If you look at how many modules you need to deliver, it turns out that even a country like the United States cannot do it. Cooperating with other countries in the era of the polar world is also a rather dubious option. As I have already said, all construction on the moon should be carried out using 3D printing in order to simplify and reduce the cost of this construction as much as possible. Here is such a solar printer with a film mirror, which will have a small mass, about 300 or 400 kilograms. It is being developed in Russia at Samara University. Just with the help of 1 or 2 landing stations, construction of the depths of Mars can already begin. In Russia, there is a group that develops lunar bases themselves and various construction equipment. This is a group led by the Institute of Astronomy of the Russian Academy of Sciences. The Royal is called. It is being developed in combination with the Moscow Architectural Institute and the Moscow Polytechnic University. And I am the coordinator of the development of this lunar station, and, of course, taking this opportunity, I want to say that we are open for cooperation and ready to interact with other design groups, including design, interior, and architectural design. This is what one of the modules looks like inside. This is a greenhouse. All these modules that you see are hexagonal. They are designed for one purpose or another. These can be cabins, life support systems, flight control centers, residential modules, production modules, office premises and so on. Therefore, it is necessary to develop a design project for each such module, which is what we are doing now. What can I say in conclusion? People who work in hard, dangerous jobs and artificial intelligence that composes poetry and paints pictures. I think this is not at all the future that we would like to see with you. Therefore, I sincerely wish you creative success, simple human happiness, and always hear the quiet voice of truth, which would tell you what to do and what not to do. Thank you all for your attention. See you soon.